The second method of preparing the ethers is the Williamson synthesis. It's basically the method which is used to prepare unsymmetrical ethers, and it involves the reaction of an alkoxide on alkyl halide. So it is a nucleophilic substitution reaction. Let's keep it R dash. So what we get is R dash OR plus NaX. Now what you need to know is that if we want to prepare, if we have taken sodium tert butoxide and we have taken ethyl bromide, remember what happens is this as a nucleophile attacks on this the ethyl bromide, and this results in the formation by SN2 mechanism this ether. So what we get is which is called tert butyl ethyl ether, or it is called 2-ethoxy 2-methyl propane. Now this ether, small amount, this NABR is also formed. Now this ether, the unsymmetrical ether, cannot be obtained by taking these reactants in the other way around. Like we cannot take to prepare this tert butyl bromide and sodium ethoxide. The reason being then tertiary alkyl halide, if it is tertiary and we have such a strong base, it will not give us what, let me read about this name, this will not going to give us this product in any case. It will give us what? An alkene. Elimination reaction takes place. It will give us alkene. That's the most important thing in this case. The product obtained will be, let me read about this one, if we take for the reactants in this very similar way, the product will be this compound and not a substitution reacted product. So we will get this compound rather than anything else, in this case alkene, ethene, like in this case it will be 2-methyl propene will be product obtained. So that is what we have to remember, that Williamson synthesis is always to be allowed through SN2 mechanism, and therefore the alcoholic part, the alkoxide part has to be as big as possible, tertiary or more, tertiary or higher, and the alkyl halide part has to be primary or secondary. Otherwise what happens is elimination takes place. I can give you one more example to explain you specifically in the case of aromatic ethers. Like suppose we want to prepare anisole. Now anisole can be obtained by two ways. We can take sodium phenoxide and methyl bromide, or we can take bromobenzene and sodium methoxide. Now the question comes is, which out of these two reactants is going to give us anisole? This is going to give us anisole, not this one. Why? You need to remember this, that the aryl halides, due to their plus R effect, are having what? CX as partial double bond. CX as partial double bond. And we know that therefore aryl halides doesn't show nucleophilic substitution reactions. How it is possible? Moreover, what we need to know is this phenoxide, due to what? Plus R, is having what? Partial double bond character. Oxygen, so oxygen is the one which will act as a nucleophile and will attack on this one. And that is what again is this, you have to take the alcoholic part as bigger as possible and the alkyl halide part as smaller one, and that is how we can get even the aromatic ethers.